Right, so we get given a circle with some details, and they want us to find the equation of the tangent at the point minus 6, 9. Well, let's put the details on the circle. We know the center is negative 4, 5, and we know the radius is root 20. And I'm a spatial person, so negative 6, 9 has to be somewhere up here, which means the tangent is got the gradient of the circle, which is perpendicular to the gradient of the radius that goes to the center of the circle. So we can find that out because we know both ends of that. The gradient of that radius is 9 minus 5 over negative 6 minus negative 4, which turns into negative 2. That means the perpendicular gradient is the negative inverse, so it becomes positive and it becomes 1 over 2. With the point minus 6, 9, it's quite easy to find the equation of the tangent now. Let's use y minus y1 is m, x minus x1. We put them in. Y minus 9 is a half of, in brackets, x minus negative 6. Technically, that is the equation. We can make it look a little nicer. I'm going to multiply both sides by 2 and get 2y minus 18, and is equal to, when you subtract the negative, it turns into plus, so we have x plus 6. And pull everything to the same side. 2y minus x minus 12 equals 0. That'll do. For part B, we need to find the equation of the circle. Well, we know the center and we know the radius, and we know the generic form for a circle is x minus h squared plus y minus k squared is equal to the radius squared. And the center is the hk and the radius is the r. So let's just put those values in. Get x plus 4, because we're going to subtract negative 4, squared, plus y minus 5 squared is equal to root 20 squared. Well, expanding the brackets, x squared plus 8x plus 16, and for the y's, we get y squared minus 10y plus 25. If you square a square root, you just get back to what you had. So we're at 20. Bring it over, subtract 20. It equals 0. Collect like terms. It's just the constants. X squared plus y squared plus 8x minus 10y plus 21 is 0. For part C, there's a few ways we could do this. We could find the y-intercepts. That's where x is 0. I'm going to work with the triangle because we know the center is 4 units away from the y-axis. And we can cut that angle theta in half to make a right angle triangle with a hypotenuse of root 20, and one of the sides is 4, which means that cos of alpha, I'm going to call it alpha, is 4 on root 20. Alpha is the inverse cos of 4 on root 20. And if we put our calculator in radians mode, it's going to be very helpful. We'll get 0.4636, corrected 4 decimal places. But the theta, the angle that we're looking for, is 2 times this value. So use the exact value on your calculator, multiply it by 2, round to 4 decimal places, and you get 0.9273, which is the value of theta correct to 4 significant figures. And finally, we need the perimeter and area of the segment shaded in the diagram. All right, let's construct a little diagram so we can see what's going on here. And the perimeter is the arc plus the length along the y-axis. We can find half the length, we call x, by saying x squared plus 4 squared is root 20 squared. Root 20 squared is just 20, 4 squared is 16, 20 minus 16 is 4, and the square root of 4 is 2. So x is 2, and then we double it to get the chord, the full straight length, which is 4. The arc length is r theta, where of course theta is in radians. So we have root 20 times what we just worked out, 0.9273. Use the exact value again, and we'll get 4.147. Let's add the 4 to that and get 8.15. Well, that's rounded to 3 significant figures for the perimeter. The area, we'll do the area of the sector, which is a half r squared theta, and we'll subtract the area of the triangle, which is a half AB sine theta, but A and B are both the radius, so half r squared sine theta. We can factorize the half r squared out and get a half of root 20 squared, which just turns into half of 20, which just turns into 10. And we'll have theta, which is 0.9273, minus the sine of theta, which is 0.9273. And make sure your calculator is in radians, or that won't work out well for you. We just get our answer, which is approximately 1.27. And that's it. Question over.